Did you know it's super easy getting started with a bunch of different Azure dependencies and resources right within Visual Studio? Learn more on this episode of Visual Studio Toolbox. Hello, everyone. Welcome to another episode of Visual Studio Toolbox. I'm your host, Leslie Richardson, and today we are going to skip the Azure portal and just directly talk about how to add your Azure dependencies directly inside Visual Studio. And joining me today to talk about that is Angelos from the Visual Studio Web Tools team. Welcome, Angelos.
Hi, Leslie. Thank you for having me. I'm very excited to chat to you today.
Yeah, thanks for being here. So can you tell us, can you tell us a little bit about yourself and what exactly all this means and Azure dependencies, why they're important, all that jazz?
Yeah. So I'm a product manager for .NET, but the last few years have been working in Visual Studio with the Web Tools team, primarily looking at experiences that helps connect applications to a bunch of different dependencies, including dependencies in Azure. So today we will be looking at connected services in Visual Studio, and connected services is our brand for just helping you connect to a bunch of different services, whether they're Azure or not. And that's where we use the terms of service dependency to mean Azure, or a service reference to mean OpenAPI gRPC. I'll get into that in a minute. The thing to take away is that connected services helps you connect your application to a bunch of different dependencies, including Azure. And today we're going to look at the Azure Functions and the ASP.NET Core Web API project types as a real showcase of how that works. We're going to look at support for local emulators. We're going to look at complete different alternatives for Azure services. Like maybe you want to use Azure SQL Server in production, but maybe you want to just use SQLite locally. Integration with container tooling in VS. If one of your dependencies cannot run locally, we will run it in a container for you. And we just don't make it hard. We just make it as simple as when it's not in a container. We're going to look at integrations with third-party tooling. We have support for RabbitMQ, for example, and we integrate with our management portal. And then we're going to show how VS is helping us generate as much of this code and configuration as possible. There's still some opportunity to do better, and we hope to get your feedback to get even better. But I think you'll be impressed with what we can do today already.
So exciting. So let's just jump in.
All right. So do you mind if I just jump in straight to the connected services view first? I want to show you all the connections we have. All right. And then we'll take it from there. All right. So here's my my solution in Visual Studio. I have 3 projects. The message models is just a class library that has a couple of classes that represent things I have in the database, an employee and an order. Don't worry too much about that one. We're probably not going to talk about that one anymore. Here I have my Azure Functions project, and I'm going to click on the Connected Services node. If I expand it, I can see things inside the Solution Explorer view, but I'm going to just double click on it because I want to open it nice and big on the left-hand side.
Yeah, so I didn't even know this pane even existed, to be honest. So that's really cool in and of itself, just to see all these different connections that you can do directly inside Visual Studio.
Yeah, and we're trying to kind of make it, connected service is such a broad term. What are you connecting to? We're trying to kind of help people discover it and understand what we're connecting to. So on this page, you will see two main sections. The bottom section, which I kind of mentioned earlier, called Service References. That's, again, about dependencies, but it's about custom dependencies. Either you've made an OpenAPI or gRPC service yourself that you're talking to. Maybe it's microservices-based. Maybe you have a WCF web service that you're consuming. Connected services absolutely is about connecting to those type of things as well. We're not going to be spending too much time talking about that today. I'm going to focus on the top level, which is service dependencies. And through that, we expect you to connect to things like real products and services. So you will see things like Azure services, SQL Server, and things like that. So I want to just take a minute and just take you through everything that this project is connected to already, just to give you an idea of the scope of what we're going to cover. I have an application insights dependency, and this is local right now because I chose not to connect to a live Azure App Insights instance. We are connected to Azure Cosmos DB, and this is a real instance that I've named it Angel P orders Cosmos DB. And my code is consuming that dependency through the connection string Cosmos DB connection string. That was just my choice. I chose to name it that. It could be named whatever we want. Then I have the Azure Signal R service that I'm connecting to. Have you used Azure Signal R before by any chance?
I have not, but
right,
I'm
so Signal,
quite familiar with it. But yeah, go for it.
I'm sorry. I'm so excited about SignalR. It just opens up so many possibilities. It's the idea behind real-time communication. So if you have a web page and you want to update it live, you can use SignalR. If you want a lot of different people to get the same update, SignalR is a great use case for that, and it scales like crazy. So yeah, we'll talk more about that in a minute and how we're making use of it. Then we're connecting to RabbitMQ, and that's connecting via a container because we cannot run RabbitMQ locally on the machine very easily. So we're containerizing the dependency.
Can you explain what RabbitMQ is?
Oh yeah, so RabbitMQ, it's a very popular and reliable messaging service. So the idea is you have a message, and you're not interested in processing it synchronously. You want to put it in a queue and make sure it's safe, and then you want people to be able to pick it up from the queue, work on it, but never risking losing it or corrupting the message. And that's kind of where RabbitMQ comes in. There's other alternatives too.
Cool.
So this is running on a container, and my code is going to make use of it through the RabbitMQ connection string. Again, it's a name I chose. Then we have a dependency on secrets.json. So this is the local story for .NET and managing secrets. You know, some people may say, "Why is that really a dependency? That's just a project artifact." I can see the argument in both cases. The reason why we decided to make a dependency is because, in theory, you could grow up the story of user secrets and say, well, in my pre-production environment, I want to keep my secrets inside a Key Vault instance. And the two can be interchangeable. And that's why we represent as a dependency, so that at any point you can say, oh, swap that out for Key Vault, and it's as easy as right-click swap rather than changing code at all. And then finally, we have our dependency to the Azurite storage emulator. And that's running locally on the machine, and it's kind of a requirement for Azure Functions. I'm going to go and do the same for my web API project as well. I'm going to double-click on the connected services of that one. And I'm going to show you that's also connecting to my Azure Cosmos DB instance, similar connection string name, and connecting the same instance. We have a recommendation to use Azure Key Vault, but I haven't connected that up yet. I'm still using secrets.json here like I did in the other project. And here I'm also connecting to SQLite. It's running local on my machine. It's not containerized. All right, so on your butts of things, what are all these things doing, right? Let's zoom out for a minute. All right, so this is what we have in Visual Studio between those two projects. I'll explain this very quickly, and then we're going to jump straight into the code and the tooling, right?
Great.
Think of this as kind of like a generic messaging system. I've kind of modeled it here under the idea of it's an order processing system, like maybe you have a warehouse where you're fulfilling orders, but same concept applies to maybe a kitchen order, or maybe have a work item that gets assigned to a developer to work on it. So we basically have an incoming message, and that message is going to go to our RabbitMQ. And we then want to be notified when that happens, so that we can, first of all, timestamp when we receive the order. And then we're going to assign it a tracking number so we can follow the order through the processing pipeline. So over here, immediately you might be thinking, well, how is that going to work? Is that going to be using polling? Is that going to receive an update? If two things happen at the same time, will this be processed sequentially or in parallel? So immediately, this is starting to look complex, but I'm going to show you how in VS, none of that is your concern. So the Azure function is going to take the message, timestamp it, and assign it a tracking ID. And then it's going to go back into a queue waiting to be assigned to an employee to fulfill it. We could have put it back into a RabbitMQ, but just to keep things interesting, we decided to go and put the message into Cosmos DB, and then we're going to get a trigger from that. So we want to know when something changes in our Cosmos DB. We want to receive the update, the notification, and then we want to do things like, well, do we have any employees that are currently available to assign the order to? So then we're going to use our web API to talk to our operational database, which is running SQLite on my machine. And through the API, we'll be able to retrieve the employees, assign one of them to the order. And while this is happening, we're also going to send a real-time update to our dashboard, where you can imagine different employees or managers are watching the orders coming in and them being assigned. That's going to show the real-time updates through Azure SignalR.
Wow, that's
How does that
really
sound?
cool. Yeah. I do like this map. I do think that helps a lot, but I'm sure it's even simpler in VS. I know earlier you brought up having like a web server that's not running on a server, but servers in the title. So how's that working?
Yeah, I think when I get to the dashboard, I'm going to show you how we're basically serving the dashboard through an Azure function. So it's serving a static file, but because I'm using Signal R, this statically served web page is going to be alive and it's going to have updates. And I'm going to show you how to easily do that, both on the front end and the back end.
Pretty sweet.
Right. Oh yeah, I think that's pretty cool. And again, this isn't supposed to kind of be best practices as to how to scale in Azure or something like that. This is just creative and interesting things to kind of get your thoughts going and maybe look for people to look into their own use cases, how they can combine some of the things to do interesting stuff.
Awesome. Experiment.
Yeah. All right, I'm going to jump into the code. All right, let's go and check our very first stage, which is processing the incoming message. So I'm going to open up my message processor class here. This is my Azure function. And if you're new to Azure Functions, I think you will find it relatively easy to kind of read through to understand what it's doing. So I have my run method, and you can see that I have named this through an attribute. And you can name this the same thing as your class, so it's completely up to you. But the main important thing is the arguments coming into the method. So the first one says, well, this is triggered through RabbitMQ. So immediately I know this is an Azure function that is going to receive an update from RabbitMQ. And the second piece of information is, well, that queue is going to be called unprocessed message. I gave it that name. It could be whatever name we want for the queue. And then we're saying, well, how do we connect to this RabbitMQ? Well, don't worry about it. There's a connection string. This is the name of the connection string. And I will show you in just a second how Visual Studio helps you set that up without you ever having to even know the value. And whatever message gets put in RabbitMQ, we're going to receive as a parameter inside this variable called queueMessage. So I don't have to worry about polling. I don't have to worry about things being processed sequentially or not. I'm just creating an Azure function, and I'm saying, please let me know when there's a new RabbitMQ message. All right?
All right.
If you remember, the next stage is to kind of timestamp it, give it a tracking ID, and then go and put it back into Cosmos DB so that the employees can be assigned to it and somebody can work on it. So the output of my function is going to be a Cosmos DB output. The name of the Cosmos DB database and collection is order database and order container. I just chose those names, and that's just how you get from the server down to your container. That's how Cosmos DB works. And how do we connect to this instance? Well, don't worry about it. There's a connection string with this name, and I'll show you how VS helps you with that connection string as well. So only thing we have to worry about is an out variable. It's a document. So anything I put in this variable, Azure Functions is just going to go and persist it into this connection that I have here that VS is going to help me set up. Cool so far?
Yeah.
All right. So the actual code, it's just very simple. I generate a new GUID. Then that will be my tracking ID. So then I'm going to make the record I want to put in Cosmos DB. So I'll create a new my document variable because it's an out variable. It's just good practice for anything that goes in a database to have an ID. So I just gave it an ID and I gave it that GUID. Don't have to. It could be a string. It could be whatever. But I decided there's going to be a message details property. And in there, I'm going to put the incoming message from RabbitMQ. Then I decided there's a property called message received time. I decided that name, and I am giving it the current timestamp based on UTC right now. And then I created the tracking ID field, and I'm assigning my GUID to that. And the rest is just logging. I also have a parameter that helps me do my debugging and my logging. If something is interesting, I want to log it via text. I can also do that. So that's it. This is all it takes to receive a message from RabbitMQ, process it, and put it back in Cosmos DB. So how much of this... Go ahead.
Well, I was just going to say that seems so streamlined than how I'd imagine it might normally go, where you might have a bunch of files going on, and then you have to worry about just a bunch of different syntax. Yeah. It's probably not going to work the first couple times around. Yeah, so it's cool to see it all contained in one class, basically.
Exactly. And it's kind of very easy to understand. And now you're thinking, okay, how can I get away without even having to remember the syntax? All I want to remember is just this bit here, right? My business logic. So let me jump over to another instance of VS I have over here, just to show you that I can just create a brand new project from scratch, an Azure Function project. I'm just going to call it my demo AZ app. Just to show you that I'm doing absolutely nothing under the covers. And immediately here, Visual Studio is going to say, well, you want to create an Azure function. What do you want to connect it to? And here's all the list of possible integrations with Azure functions. You can do Cosmos DB. You can do Blob. You can do HTTP. I'm just going to scroll and find the one I chose, right? Where was I? RabbitMQ. That's the one I've used in this example. And here, I can provide my connection string name, and I can say this is my RabbitMQ connection. And I can just click create. So it's almost already working. Like it's almost already there. What if I want to add something else? What if I don't remember how to connect to Cosmos DB? All right, I'm going to right click on my project. I'm going to click add, and I'm going to say new Azure function. Okay. I'm going to say, yes, it's an Azure function that I want. And I get a similar list to before. The UI looks a bit different. We're doing some work to merge the UI, but the items listed are exactly the same. It's the same feed. So I'm not going to pick the RabbitMQ again. Let me pick the Cosmos DB one this time. Okay, so I'm going to say my Cosmos DB triggered Cosmos DB connection. There's a connection here. I'm going to leave these as default. I can give them whatever value I want. And this is where VS goes the extra step for you. If you already have your Cosmos connection set up, either because you followed the tutorial, or maybe it's a code sample, or you copy paste it from another project, that's fine. Just clicking add here is going to give you the code that you need for the syntax in the Azure function file. But if this is a brand new connection that you have never configured before, like I am doing here, I have not configured Cosmos DB before. If I just check this box here, after the function is created, Connected Services kicks in and says, it sounds like you want to connect to Azure Cosmos DB. Do you want to do that via an emulator, or do you want to do this with a live service? I can choose to fulfill the dependency via the emulator, and then it says, oh, well, I can run this in a container for you. That's all you need to worry about. Or I can say, you know what? Connect me to a live instance. It knows my Azure login. It knows the subscription I typically work in, although I can change that. And then it's immediately going to list everything that matches this dependency. Now, I only happen to have one instance provisioned so far, but I can just click the plus button and provision a brand new instance without ever leaving the ID. I'm not going to make you kind of provision a new instance and watch the spinner go, but let's pretend I'm going to use the one I've created a minute ago. I'm going to click next here. And I already told it I want it to be called my Cosmos DB connection, so it's not going to bother me with that input again. It has already figured out the connection string value. And because it's a secret, it's even hiding it from me. If I want to look at it, I can click show secret. Or I can go look at it where we save it. But this is the kind of the point of Visual Studio and integrated tooling, is that you don't have to worry about these things.
But you still have the option to if you want to.
Yeah, because we don't want to put anybody in a corner.
Absolutely, yeah. And I just like this step-by-step walkthrough. Because I know sometimes when you're getting into the different Azure services, at least for me, it can be a little overwhelming. So it's nice that they're like giving you the option to get some hand-holding what to do and how to easily start connecting.
Yeah, the idea is we try to kind of show you the options you care about at each step, and rather than show you everything you care about all at once, which can be intimidating.
Right. Yeah.
All right. So the last choice that you can make here as a user is you can go with the defaults, which is secure by default, which means any secret type of any type of secret application secret will go into the .NET user secrets file that it's outside of the repo, so it doesn't get checked in accidentally. That's default behavior. But VS is fully integrated with Key Vault. So if you want to put every single secret into an instance of Azure Key Vault, it's just a radio button away. For now, for my local F5, I think most people want to use the user secrets. It just makes sense. So I'm going to showcase the most common example. I'll click next here. And now VS is going to give me a little summary of everything I have picked so far and I've asked it to do. And it says, you want to configure Azure Cosmos DB. you want a new Azure function out of that trigger. You want to put the connection string into the secret store. And if there's any NuGet packages I need to update for you, I'm going to do that as well. So I'm just going to click finish. Everything is set up. And here's my Azure function ready to connect to my Cosmos DB. And this is just going to work.
Awesome. Love that scaffolding there. Didn't have to do much.
It's just lovely. Yeah.
Yeah. Because I mean, I'd imagine I'd just be spending so much time just trying to figure out what wire connects to what wire, essentially, which you don't need to do here. It's awesome. It saves a lot of time.
That's right. That's the whole point of all this tooling. It's just to keep you on your task. You don't have to worry about, oh, I forgot this, I forgot that syntax, let me go read those docs. That's why it's all integrated.
Absolutely.
All right, now let's go look at what happens after the message gets put into the Cosmos DB, because I want to show you how we connect with the web API, and then I can talk about the web API stuff. I'm going to open the message dashboard file, which is, again, a bunch of Azure functions, and I'm going to scroll to the one called broadcast. I gave it that name. I didn't have to give it that name. I just like it because I'm going to broadcast the assignment of the order to everybody. That's why I named it that. So here, you should be familiar with this already. It's a Cosmos DB trigger. We just created that in the other project.
Yep.
Connecting to the order database through the connection string. Nothing new there. But the difference is my output is not going to be Cosmos DB or RabbitMQ. My output is going to be a signal R broadcasted message. So here I am telling Azure Functions that I have a signal R connection that I decided to name Message Hub. That's just my friendly name for it. I could have called it whatever I wanted. And the signal R messages, the ones I want to send out, they're going to be through this collection. So I have this variable called signal R messages. If I add the message to it, it's just going to get broadcasted. And I have my logger in case I want to do any debug output stuff. All right, so here, the very first thing we're doing is we're trying to figure out how to connect to the web API backend, because we don't want to hard code the URL in case it's local or it's running in Azure or whatever. So why are we doing that? Let me pause here for a sec and jump to the other project and jump to the connected services of that project. So here I have a web API that is connected to both Cosmos DB and SQLite. And the reason why it's doing that is because the orders, let me expand my data folder here. My orders are stored in Cosmos DB. So I have an order context class here that is entity framework enabled, but it's going to connect to my Cosmos DB. And I have an employee context class here, which is, again, an entity framework class that is going to give me access to my SQLite data store. To get this to work, I have to do a couple of things. I have to set up the configuration, the connection strings, and then I have to come into program.cs, where my application is starting up, to configure the ASP.NET IOC story. So here, I want to be able to register with ASP.NET the services, the DB context for SQLite. So here, I have to write some hard-to-remember syntax as to how to configure that. And then I have to do something even slightly more complicated for Cosmos DB. It just takes a few more configuration values. And I never remember how to do any of this stuff. I usually have to look it up.
Yeah. Copying and pasting, don't know syntax, off the top of my head.
Exactly. Because you do this once, it starts working, then you don't have to worry about it again, right? So you're not going to forget. Okay, so how did I get here? How did VS help me write all this code? It's a two-step process. So the first thing I did was I went and connected to something. So let's go back here. Let's go right-click. Actually, no, let's just double-click connected services. I could show you how right-click add also works, but I'll do it the consistent way. I can come in here and I can click plus. And I can get a list of every dependency I want to connect to. And we're adding to this list pretty much as fast as we can. That's why we also had to add the search functionality, so we can also look at the results relatively quickly. So we would love feedback from people. If there is a connection or a dependency that they are often working with and it's not in this list, please let us know your use case and what it is, and you'd be surprised how quickly we will add it. But here I want to show you that even if I just type SQL, I get a bunch of options. I get SQL Server Local Express. Sorry, SQL Server Express Local DB, which I can use locally. I can use SQL Server in a container. I can have an on-prem SQL database. I can connect to Azure SQL Live. I can connect to Postgres. as long as Entity Framework supports more stores, we're going to keep supporting more stores as well. So the idea here is that first I can connect to something, and I connect it to SQLite, or I can connect to Postgres. And then, let me go back to my other project here. I want to generate my controllers. I want to generate this API, right? So let's take a look at the employees controller. I have some gets, some get employee, get employees, put employee. Okay. How did I get that? I'm going to right click on my project. I'm going to say add new scaffolded item. And I'm going to say I want an API controller using Entity Framework. I'm going to click add. And this is the kind of the view that I worked with when I first created the project. It asks me for a model class. So this is saying, well, you're going to make an API for what? For a customer, an order, a message. What is the class that you want to make an API for? What are you going to put, get, delete, all that kind of stuff? So here, I'm just going to pick one of the classes from my class library, the employee class. It's just first name, last name, and ID. Now, I did not have a data context class when I started. So at this point, I click add. And Visual Studio is going to generate a new DB context for me. Now, I did that, so I can just pick it from the dropdown. I don't have to create it again. And finally, I'm just going to name my controller. So let's just put the ending 2 here, so it doesn't kind of override what I have already. And let's see what happens. All right, so scaffolding is kicking in. And the first thing that it's doing is it's checking, is my program.cs configured correctly for this scaffolding action? So in program.cs, it's going to go and check, have I already configured SQLite and Cosmos DB? And if not, it's going to add that configuration for me. And it's doing that while it's generating the controller. So my end-to-end just works.
That's cool. So what happens if you technically do try to connect that SQL stuff on your own, but maybe it was done incorrectly? Would it be able to account for that or
so
no?
if you have, it depends on how broken things are, right? Because in most cases, the answer is yes. At any point, I can come back to the connected services view and say, you know what? There is something wrong with this connection. I don't know what's going on. I'm going to click edit dependency, and I'm just going to reconfigure it. I'm just going to make sure that the instance is set up correctly. All of the settings are set up correctly. My NuGet packages are up to date. That's step 1. If this connection works properly, then we're to the scaffolding aspect of it. As long as Visual Studio can find the correct assets, that scaffolding action is not going to fail because it doesn't have to connect to anything live. So that has a much higher probability of just working correctly. If you tried to create your own controller and the controller is just kind of not working, or it's halfway working, just generate a new one, and you can do a diff to see what we do differently. And if you want to copy paste code around, you can do that. But the output of the scaffolding is pretty complete. It's not just not implemented methods. You actually get most of the functionality of, can you find by ID? Can you delete by ID? So you can actually see the best practices as well, and hopefully figure out what is broken on your attempt.
Sweet. I do like that it accounts for some user error there.
Yeah, and at any point, you can just come and delete all this stuff and just do it again. That will also work. All right. So here I have my 2 APIs. One is on top of Cosmos DB. The other one is on top of the employees. I'll go back to my original Azure function. I'm going to go back to the dashboard and show the broadcast method. All right. So this is where we retrieve the URL for our API. And all we're going to do is the results is the variable that is passed in. We're just going to load the results. We're going to say, well, this trigger from Cosmos DB contains a new message in it. We're going to load that message. And as long as it's not empty, then we're going to find the first employee that is available and assign them the order. Now, this could get very fancy. I've done something extremely simple, which is I call the API to retrieve all the employees. So this is the base URL that is coming from configuration. I'm going to call the get employees method. We're going to get the whole array of employees. And then as long as there's at least one, we're going to pick a random one. Now, I could have done this based on their workload. I just wanted to make something simple. So I'm just going to randomly pick an employee. And then we're just going to assign the employee name to the order. And then I'm going to call back my API again with another method, HTTP put this time, to update the order. So in this in one swoop, I have used my API to connect to Cosmos, retrieve some stuff, connect to SQLite, retrieve some stuff, work on both, save both, and we'll move on with what called this function as part of broadcasting. So the last thing we have left to do here is to tell all the dashboards that what we just did happened. So we just took an order and assigned it. So here we're gonna take our orders and we're gonna load them up. We are going to generate the message based on what we just did. And this is me being lazy. I could have done some fancy CSS stuff here, but I just have just some simple strings that, hey, here's all the messages. Here's the most recent, here's every order, here's every message, and here's the most recent message. And here's the tracking ID, blah, 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 blah. All right, let's go back. So how does this work? Here, now that we have the message generated as a string, we want to send it out using SignalR. Because of Azure Functions and .NET and the tight integration, I already have a variable to put my SignalR message in. So literally, all I have to do is say add asynchronously, because I don't want it to block. I just want to add a message to this variable. I'm going to new up a new message. Target is just a property that you can assign so that it's a friendly name. Imagine that you have an app that receives many messages. Maybe a message is about the profile information was changed, the orders were changed, somebody was hired or not hired. You can just target the message with a friendly name. I just chose to call it new message here. As long as on the other side, I look for new message, that's all that is. And finally, piece of resistance, we just put our message inside the arguments as a string. Where is this going? Like, okay, this was easy enough, but what is happening here? Like, there's a SignalR, and how do I get this property first of all, and where does it go afterwards? Mm-hmm. All right, I'm gonna go back to my little project here. I'm gonna click add. I'm gonna type SignalR. I'm gonna say SignalR, thank you very much. It's gonna say, great, here's a bunch of instances already provisioned. I can always provision a new one. I don't wanna do that right now. I will just pick one I had created before. I'll click next. It's saying, you probably want a connection string name for this. I recommend this one, it's best practice. I'll keep it. The connection string value, like before, it's a secret. I don't have to worry about it. I'm gonna click next. Here's a summary of what's about to happen. I'm gonna click finish. And now I have a working instance of SignalR. I don't even know how to provision this with the portal. I will never have to find out. So now I just wanna know how to consume the SignalR inside my client, my dashboard, because the function is gonna trigger it, but who's gonna be listening to it? Great. Now, remember when I said about Azure Functions being able to do something cool, like serve static content? So here I have an index method, and that's an HTTP trigger. So basically, this function is triggered when you make a call to it, an HTTP call. And there is absolutely no authentication on it. It's completely anonymous. Anybody that comes to it can read it. And all this is going to do is serve the content that I have on a file called index.html. So this is serving static content. I could have retrieved it from Azure Storage if I wanted to. Could have retrieved it from a cache. I just have it here. If I expand content and I double click on my index file, this is my dashboard. So what I have here is a very simple web page with a title. It has a div where my SignalR messages are going to go into. I import what I need to be able to work with SignalR. And then I have a tiny bit of code that says, well, I'm going to find the messages div, and then I'm going to connect to SignalR. Window.location.origin gets me the base URL, and then I'm going to establish the connection. This is just how you connect to any SignalR hub. And then I'm just going to say, if at any point I receive something called new message, by the way, let's go back to the dashboard. This is just a string here, as long as those two match, right? And what am I going to do with it? I'm going to update the page with the messages. And this is all that is needed for my Azure function to be able to serve this index HTML statically, but now every time my Azure function does something, it's going to let everybody who has that file open what happened, and everybody's going to see the same update instantly, all at the same time. All right. So the final piece I wanted to show you is I showed you some integrations with the Azure portal and being able to provision new instances. I showed you scaffolding for Azure Functions and the Web API. But what about a more complete end-to-end? What if we want to work with third-party tooling and third-party integration points, like the RabbitMQ, for example? So this is actually a true story. I went away for vacation, and I came back, and my dev lead said, we've implemented RabbitMQ. You should check it out. So I had never used RabbitMQ before in my life. I didn't know how it worked. So all I did was I went to the Connected Services tab. I clicked Add. I installed it. I got it configured. I didn't even know it was running in a container. It just told me it was running in a container. I was like, okay, well, that makes sense. And then I asked my colleague, well, how do I use this? How do I send a message? How can I test it? He goes, oh, that's all integrated. Just go under the actions and just say, do you want to see the container running in the containers window? You're trying to stop it? Or do you want to manage its end-to-end lifecycle and put some test messages in it? I'm like, oh, that's pretty cool. I didn't know RabbitMQ did that. So I come here, I click Open in Management Portal. And this is the RabbitMQ kind of dashboard. It's the admin view. We have not built this. This comes from RabbitMQ. And I can just use this to go to my queues, for example. This is my unprocessed message queue that I created earlier. And I can even go and put test messages in here. And this is how I actually test my inner loop. And this is very similar to what we do with Web API projects, where as soon as we run them, you're going to get the Swagger UI that lets you interact with the Web API live and be able to use it and have your dev inner loop without you having to do anything special. Go out of your way to get test data in there or to kick off execution to test the connections and the triggers. Let me show you that. I'll come here, check out, execute. Here's all my employees. Here's all the people in here. And the same thing goes with more integration points. And I know we said we don't love going to the Azure portal, but sometimes we just have to. And that's also another great opportunity for VS to help you out. You don't want to go and try and find the instance in the portal, search for it. Just come in here, click Open in Azure portal. It's a dim link right where you need to be. Hopefully, it will save you some time. But here's where I would love feedback from whoever is listening. If there's any integration point that we feel is missing, if there's something people do every day, it's something is hard, people forget, I would love to have that feedback. And again, you'll be surprised how quickly we will turn around such an improvement.
Nice. Yeah, it's really cool to see how quick it is to get to that testing phase with all the basically, I guess, the walkthroughs and that are integrated into VS. So
mm-hmm.
Oh, go ahead.
Oh, I just wanted to take you through the list of all the connected services to kind of let you go with that thought. But did you have a question for me?
Oh, well, I mean, we're getting kind of short on time. So actually, to summarize, I guess what's next for connected services? Obviously, there's a lot of dependencies that are available now, but what's coming?
Absolutely. Yeah, so we would love feedback for how can we add more dependencies, more types of dependencies to connect to. And again, like I said before, if it's something that you do often, or it's something that is really hard to set up, that's a perfect candidate for us to tool. We would love to know how to make integration more end-to-end and just everything to feel like one. We have already feedback on Entity Framework and creating migrations, executing them, and bringing them into connected services. We have plans on doing that. So keep your eyes open for that in the next few releases. And I think I should come back at another time and show you how we can take all of this and through CI/CD, put it in Azure, and how Visual Studio helps me both generate the CI/CD and manage the dependencies for my CI/CD pipeline.
Awesome. Yeah, can't wait to see all that. And yeah, definitely love to have you back and essentially like a part 2 of sorts. So for people to get started on these particular Azure dependencies and getting set up with that, where should people go?
So for our documentation, So I got a couple.
And
of
we can put
so
documentation in the comments below, no worries, or description below.
I mean, all I say to people is create a new project and just go to the double click on the connected services node, bring up the view, and start connecting things to your application. And it's both a learning experience, but you will also start seeing what it can do, and it will open up your mind into things that you can do for your own use cases. Like I showed you here, I didn't even know we could serve something statically through Azure Functions and then get it to have live updates with SignalR. I didn't even know that RabbitMQ had a management console and I could test messages so easily. I love just being a better developer and just learning things, cool and cutting edge things, just by using my favorite tool. Like I feel like I get that for free.
Absolutely. Well, good stuff. Thank you so much for joining us today, Angelos. I think that it's always nice to have things that make Azure dependencies and resources like this more accessible to people. So yeah, I hope everyone goes to try it out. All right. And with that,
thanks for having me.
Yeah, thanks for being here. And with that, happy coding.